welcome to True Projects. In this video, we are going to explain about the project that is a lightweight and efficient IoT intrusion detection method based on feature grouping. Before getting into the execution, first let us understand what is the project about. The Internet of Things, that is IoT, is growing at an incredible pace, connecting billions of devices all over the world. These devices are helping collect and share the data in real time, which is being used in so many different fields like transportation, healthcare, manufacturing, and also even in smart cities. In fact, by 2022, there were already over 12.2 billion active IoT devices. It is amazing how quickly this technology has expanded, right? But with all this growth comes a big challenge with the security. So many of the IoT devices, they have limited resources. They don't have lot of memory or also computing power. Because of this, they are especially vulnerable to attacks. Imagine trying to protect a small device with very little processing ability from cyber threats. It is definitely a tough job. These devices are often used in critical sectors, so their security is extremely important. That's why protecting them from network intrusions and ensuring their safety from cyber attacks has become a huge priority as the IoT ecosystem keeps growing. And intrusion detection system, they are like security guards of IoT networks. So the intrusion detection system, they are like security guards of IoT networks. They keep an eye on what is happening in the network. Constantly they check for any suspicious activity or potential threats. The goal is to spot malicious behavior before it causes any damage, which is really important in securing IoT devices. So here where machine learning and deep learning algorithms they comes into the picture, those models they can significantly improve how well the system detect the threats. But the problem here is the models can be very resource heavy, needing a lot of computing power and memory. And that's a problem because most of the IoT devices they don't have lot of resources to begin with. So using these complex models could actually overwhelm the devices instead of helping them. Another challenge is picking the right features from all the network data to make accurate predictions. It is not just about running the algorithm, it is about choosing the right pieces of the information. So, what this means is that we need a solution that can detect threats effectively but doesn't overload the device. It has to be lightweight yet efficient, able to do this job without draining the device's limited resources. Finding the right balance between detection accuracy and also the computational demands is key for protecting IoT networks without compromising the performance. So, to overcome with all this, the project that is the proposed system aims to create an efficient intrusion detection mechanism tailored for IoT networks by utilizing set of machine learning and deep learning algorithms. And those algorithms include decision tree, random forest, k nearest neighbor, XGBoost, which are machine learning, and deep learning models are deep neural networks and convolutional neural networks. Each of these models they contribute unique capabilities to analyze network traffic and identify malicious activities, ensuring comprehensive detection across various intrusion types. And this approach leverages the strengths of both ML, that is machine learning, and DL to enhance detection accuracy while maintaining reliability. By integrating multiple models, the system is designed to handle the diverse and complex patterns present in IoT network traffic, addressing the challenge of securing resource constrained devices. This ensures robust and scalable solution for safeguarding IoT networks from potential threats. And the idea behind this idea here is to train intrusion detection models using the data sets that represent various IoT environments, which are bot IoT, medical bot IoT, and MQTT IoT IDS 2020. So these data sets contain different types of traffic and attack patterns. So by training the model on them, we are basically preparing the system to handle diverse scenarios. It's like giving it a broader perspective so it can recognize threats in different IoT groups, not just in a single environment. So now once these models are trained, we evaluate their performance using different metrics called accuracy, precision, recall, and FN score. So these metrics helps us in understanding how well the system detects intrusions without being too computationally heavy. And the ultimate goal is to strike a balance, achieving good detection accuracy while keeping the system lightweight enough to work efficiently on IoT devices, which often have limited resources. It is all about making the practical and effective solutions. So this is the proposed system. Moving on to the extension part. To further improve the accuracy of the project, here we are incorporating different ensemble models. One is stacking classifier and the other one is hybrid LSTM model. So what this models does is, so the stacking classifier, This stacking classifier, it works by taking the outputs of multiple models and combines them to make more accurate final prediction. This helps in leveraging the strengths of different models to create a well-rounded detection system. On the other hand, the CNN and LSTM combination, the model adds another layer of sophistication. The CNN part analyzes spatial patterns in the network data, while the LSTM part focuses on the capturing temporal patterns, basically understanding how the data changes over the time. Together, these models make the system better at identifying even more complex types of attacks. Coming to the part of front end, here we have developed a user interface that is user friendly front end using Flask framework. This interface includes secure authentication mechanism. So it also includes a secure authentication mechanism. So users they can safely interact with the system through the front end. Users they can input network data and get intrusion detection. So it is not just about showing the results, but also making the system more accessible for testing and evaluation purpose. So this is the extension part and moving on to the implementation. To implement this project, we have followed the steps which are mentioned in the flow of work. Let us understand each step. I mean how we have implemented the project. So the first step comes the importing packages. Here we import all the required libraries and frameworks to handle data pre-processing, visualization, model building and front-end development. Coming to exploring the dataset part, so here in this step, datasets like BOT IoT and MedB IoT and MQTT IoT IDS 2020 are examined to understand their structure, features, and relevance of intrusion detection for the intrusion detection. Coming to data processing, here we eliminate redundant entries to ensure and clean data. After that, we remove irrelevant or unnecessary columns and we standardize the data set. So we scale numerical data to a uniform range, improving the model performance. Then we create graphs and charts to identify patterns, trends, and potential anomalies in the data. So then comes the part of label encoding. So here we convert all the categorical values that are strings into numerical representation for the compatibility with the ML model. Then comes the feature selection part. So here we select the most relevant features using statistical techniques to improve model accuracy and reduce complexity. Then we split the data into two sets. One is training set and the other one is validation set. Training set is used to train the models and validation set is used to evaluate its performance on unseen data. And the next step comes is building the model. So here we initiate all the machine learning and deep learning models and that we will be training with the data set that is training data to learn patterns and the relationships, and all the models are evaluated with the accuracy, precision, recall and fn score, and they are compared through the graphs. Coming to the part of front end, so a user friendly web interface is built with the Flask including a registration and login system backed by an SQLite database. Then comes user gives input. So here in the front end, users they will be able to provide feature values related to intrusion detection. Coming to that pre-process, I mean the given input, it will be pre-processed at the back end and that will be fed with the train model, and train model finally it will be giving the prediction and that will be displayed in the front end. Moving on to the algorithms used, these are the algorithms used in this project. So decision tree, random forest, KNN, XGBoost, deep neural network, CNN. So these are the models. All the models are used for detecting the intrusion detections. So these two are the extension models. So this is the voting classifier combining BDT and ET algorithm. ET is extra tree and BDT is boosted decision tree. And here we have also used CNN LSTM. And to implement this project, we need basic requirements, which are nothing but hardware and software. Coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB, and hard disk of 25 GB. And software are application of Anaconda, primary language of Python, front-end framework Flask, back-end framework Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. To execute, we are supposed to open the code folder that contains source code files. So let's open the code folder. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So here in the data folder, we have three data sets. So these are the three data sets that we have used in this project to train the models for detecting the intrusion detections. So individually, we will be training all the data sets. Let's get back. And here in the static folder, this folder consists of CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have multiple model files. So, so these are the model files which contain the algorithm information and that will be loaded into the project code during runtime of the application. And here this is the bot IoT process dataset. So initially, this is the dataset we have. So this dataset after pre-processing, here we have the final dataset that we will be using for training the models. So it's being loaded. Just wait for a while. Let's get back and until then we will see the other things. So similarly, here we have MetBOIT process dataset, and this is the MQTT process dataset. And here we have three sample files in which we have test cases that we will be using in the front end for detecting the attacks. And here in the last file, that is signup.db file, this file is a database file which is used to store the user information. So this is the signup.db file in which we will be storing the user information. And here we have three notebook files. So these are the three notebook files in which so these are the Jupyter Notebook files, which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So here, in this Jupyter Notebook file, we will be loading the BOT IoT process data and we will be training all the models on this data for detecting the attacks. Coming to this MedBIoT Jupyter source file, in this we will be loading this MedBIoT process data and that we will be training on this data set. We will be training all the models for predicting the attack. Similarly, this Jupyter source file also where MQTT IoT data set will be loaded and we will be training all the models on that data set. Here data set is open, so these are the different features after pre-processing and extracting all the important features. So based on this, we will be training all the models. Similarly, we do have process data in MedBOID and MQTT processed. Now let us execute. To execute, we are supposed to copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open the Anaconda prompt. So it is open. Give the command cd. It is open. So give the command cd, give the space, paste the copied path. Now click on enter. So here if you observe, current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port, unless configured differently. So this is the localhost and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. So paste the link here, click on enter. And this is the web page of the project, which is displayed in the browser. This is developed using Flask framework. So here you can see a sign up link, right? We're supposed to click on that for getting signed up. Click on that and enter all the registration details if you are signing up newly. So I have already signed up. I'll directly sign in. Click on sign in and give your username and the password. Click on sign in. We have signed in successfully and we are redirected to prediction page of the project. So here in this project, we have trained all the three data sets, right? Here we will be doing prediction for all the three data sets individually. So first, let's do prediction for BOT IoT. Click on that. So here you can see the inputs rights, the input rights. So these are the parameters need to be given for predicting the IoT for the dataset of BOT IoT. Let's understand what are these parameters. So the first parameter we have is bytes. It is the total number of bytes transferred during a network session or communication. Then we have L time. It is the last recorded time of the session or communication, often used to track the session during or completion. Completion. Then comes sum. It is a cumulative sum of specific metrics or the values such as packet counts or data volumes during the session. Then we have S bytes. So these are the total number of bytes sent, that is the source bytes, by the initiating device or system in the session. Coming to rate, so it is a data transfer rate indicating how quickly bytes are being transmitted during the session. Then comes S rate. So it is the source data transfer rate reflecting the speed at which the source sends the data. Then we have ARP protocol PSRC IP. So it is nothing but aggregated ratio of packets using the same protocol from a specific source IP address, indicating communication patterns. Then we have ARP proto P destination IP. So it means that aggregated ratio of packets using the same protocol to a specific destination IP address, highlighting the target communication patterns. The last one we have is ARP proto P sport, that is aggregated ratio of packets using the same protocol from a specific source. So these are the inputs to be given. So let's give these inputs. So those we have in the sample file. Let's open the sample file of BOT. So these are the different test cases that we will be using now for predicting the attacks. So this is the target column. So let's apply filter. So here we have total 3 classes. So let's check with the class 0, that is class 0 attack, and see whether it will correctly predict it or not. So let's check with the first case. Here, copy the bytes. I'm pasting it, that is 1580, and then we have L time, give it, that is 52808850, and then we have sum, that is 4.9, and then we have S bytes, that are source bytes, that are 814, and then we have rate, that is 0.47, and then we have S rate, that is 0.26, and then we have AR protocol IP address, source IP address it is, and then it is the destination IP address, and then we have source port. So paste it. Now click on predict. So this given information, it will be pre-processed at the backend. Then we will be getting the prediction. So here we got the prediction that attack type is HTTP DOS. It is the HTTP DOS attack. Now let's check with the other class. So here class 0 refers to the HTTP DOS. Now let's check with the class 1. So let's try with the first case for the same data set where bytes are 924, and here the L time, that is here we have entered, and the sum is 0. Source bytes are 924. Rate is 0.09, and S rate is also the same. Then we have source IP address, and then we have destination IP, and then we have protocol S port. Now click on predict. So here for the given information, here attack has been predicted, and that attack type is TCP DOS attack. So here TCP DOS attack has been predicted. Here class 1 refers to TCP DOS. Now let's check with the last class. So select it, click on OK. And now we will give this case for the same data set where bytes are 360, and the next one L time, copy it. The next one is sum, so that is 8.44. Then we have source bytes that are 360. Rate is 0.20. S rate is 0.2039. So here, the next one is source IP, paste it. Next one is destination IP, then we have source port. So paste it. Now click on predict. Here we got the prediction that attack is detected, and that attack type is UDP DOS attack. So here UDP DOS attack has been detected. Now we have completed with all the cases of the bot IoT dataset. Now let's check with the MED, that is MED-B IoT dataset. Click on that. So here you can see the parameters, right? These are the parameters need to be given as input for this dataset. Let's understand what are these. The first one we have is header length. So it is the size of the network packet's header measured in bytes. It includes metadata like source and the destination information. Then we have rate. It is the overall data transmission rate indicating how quickly data is being sent or received. Then we have S rate. It is the rate at which data is being sent specifically from the source device. Then we have FIN flag number. It is the count of the packets with FIN, that is finish flag sent, indicating the end of the TCP connection. We have ACK count. It is the number of packets with ACK, that is acknowledgement flag set, used to confirm receipt of the data. Then we have Sync count. It is the count of packets with SYN, that is synchronized flag set, used to initiate TCP connection. RST count. It is the number of packets with RST, that is reset flag set, used to terminate a TCP connection abruptly. Then we have total sum. So it is a total sum of specific metrics such as data transferred or packet counts during a session. Coming to IIT, it is the inter-arrival time. It is the time inter-arrival between consecutive packets in a session indicating traffic patterns. Then we have number. So it is the total number of packets involved in the session, reflecting the communication over volume. Then we have weight. It is a calculated metric or priority assigned to the session or communication, often used for analysis or classification purpose. So this is all about the parameters. Now let us enter them. For that, open the sample file of MED. So these are the different test cases that we will be using now for predicting. So here, let's apply filter to the category, that is label. Here we have total 4 classes. Let's check with the 0 class first. Apply filter to the class 0. Click on OK. So let's try with the first class label. That is the first test case. So copy the header length, that is 327501, and then we have rate, that is 2.033, and then we have S rate, copy it, get back and paste it, and then we have the next 3 values, that is flag number is 0, acknowledgement number is 0, and synchronized count is also 0. Then we have RST count. So copy the RST count, that is 4077, and then we have total sum, that is 456.2. Then we have IIT, that is 2.48. Then we have number, that is 5.5. Copy it. Then weight, that is 38.5. And the next parameter. So we have completed with all the parameters giving input. So click on predict. So this given input will be pre-processed, and then we will be getting the prediction by the train model. So here attack type is benign. That means there is no attack. So class 0 refers to no attack here. Let's check with the class 1. So let's try with this case for the MED BIoT dataset. So copy the header length. So copy it. That is 607.48. And then rate is 12.09. Estate is 12.09. And flag value is 0.46. And acknowledgement count is 2.06. SYN count is 2.22. And then we have RST count, that is 7.18. And then we have total sum, that is 727. And then we have IIT, that is 8466704. We have not copied it, just copy it again. So paste it here and then get back. Number is 9.5 and the weight value is 141.55. Now click on predict. So here we got the prediction. So the prediction is attack is detected, and that attack is DDoS attack. So here class 1 refers to DDoS attack in this case. Let's check with the class 2. So let's give input of, shall we try with this one? So let's try with this one. So where header length is 644.8, and then we have rate, that is 43.66, and then we have estate, that is 43.66, and then we have in flag count, and then we have acknowledgement count. SYN count is 2.81. RST count, that is 7.18. Total sum is 744.01. And the next value IIT is 84662381. And then we have number, that is 9.5. And weight, it is 141.55. So here we have given input for all the parameters. Now let's click on predict. So here we got the prediction that attack is detected and the attack type is DOS attack. So here DOS attack has been detected. Initially, For the class 1, we got detection of DDoS attack, and for this class 2 here, we got the attack as DOS attack. Now let's check with the class 3. So here are the inputs that we're supposed to give. Now let's try with this case. So here, copy the header length, that is 773, and then the next value is rate, S rate, and in flag number, acknowledgement count, SYN count, RST count, total sum, that is 346.2, IET, and number is 5.5. The last one is weight. Now click on predict. So here for the given third class label and for this test case that we have given, this is the test case that we have given. So here we got the prediction that attack is detected and that attack type is malformed attack. So here malformed attack has been detected. Now let's check with the last data set. So let's do prediction for the last data set. Click on MOTT IoT IDS. So these are the inputs that we are supposed to give. So let's understand what are these. The first one we have is TCP time underscore delta. So it is the time difference between consecutive TCP packets in a session indicating the timing and flow of communication. Then we have TCP length. So it is the length of the TCP payload in bytes, representing the actual data being carried in TCP packets. That is TCP packets. Then we have MQTT, dub flag. So it is a flag in MQTT packets indicating whether the message is duplicate, that is retransmitted, or an original one. Then we have MQTT length. So here the flag in MQTT packets indicating whether the message is duplicate. Sorry, it is the length of MQTT message which includes the header and payload size in bytes. Then we have MQTT message ID. So it is the unique identifier assigned to MQTT messages, particularly for QoS, that is quality of service, level 1 and 2 to track delivery status. Then we have MQTT message type. So it is a type of MQTT message that is connect, publish, subscribe, indicating the purpose of packet in the MQTT protocol. The last one we have is MQTT QoS. It is a quality of service for MQTT messages, defining the reliability of message delivery. For example, 0, at most 1, at least 2, exactly once. So it is like that. So here we have entered all these parameters. I mean, we have understood all these parameters. Let us enter them. For that, let's open the test case of the sample. So these are the test cases. These are the samples. So let's enter them. Here we have different targets. Let's apply filter. So here total we have 6 classes. So let's apply filter to class 0. So select it, click on OK. So these are the different test cases of class 0. Let's try with the first case. Here TCP time data is 0.001459 and TCP length is 4. Loop flag is 0. MQTT length is 2. Message ID is 0. Message type is 2. MQTT QoS is 0. Now click on predict. So here we got the prediction that brute force attack has been detected. So here there is an attack and that attack type is brute force attack. Now let's check with the class 1. We are doing prediction for last data set selected. So let's do for this case where time data is 0, TCP length is 78, dupe flag is 1, length is 169, message ID is 6146, and message type is 3, and quality is 1. Now click on predict. So here we got the prediction. Here class 1 refers to DOS. So here attack has been detected. So attack type is DOS attack. Now let's check with the class 2. Click on that and click on OK. So let's do prediction for this case where TCP time delta is 1.999846 and TCP length is 32760. and do flag is 0, length is 16, message ID is 0, message type is 3, quality is 0, quality of service is 0. Now click on predict. So here we got the prediction that attack is detected and the attack is flood attack. So here flood attack has been detected. Now let's apply filter to class 3. So let's try with this case. So this is the TCP time delta, copy it. And the next values 0, 0, 0 and rest all the values are 0. Now click on predict. So here we got the prediction that attack is legitimate attack. So here there is no attack. That is why it is showing as the attack type is legitimate. That means there is no attack here. Let's try with class 4. Let's try with this case where TCP time delta is 6.3E hyphen 05 and all the values are 0. Now click on predict. So here we got the prediction that attack is detected and that attack type is brute force attack. So here brute force attack has been detected. Now let's check with the last case. So let's try with this case where time delta is 0.000216 and all the rest values are 0. Click on predict. So here we got prediction that attack is detected and that attack type is slow white attack. So here slow white attack has been detected. In this way you can do the prediction of network intrusions. Now let's check with the graph. Click on graph. So here we have the graph. So first we have graphs for BOT, IoT dataset. This is a sample outcome graph. Here on x-axis we have the subcategories and on y-axis we have the count of that subcategories. And this is the correlation matrix. This is the accuracy comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms that are trained for predicting the attacks. And this is the precision score comparison graph. Here we have recall score, FN score. And this is the sample outcome graph for the MEDB IoT dataset, that is MEDB IoT dataset, and this is the correlation matrix, accuracy, precision, recall, and FN score. And here we have sample outcome for MQTT IoT IDS dataset. So this is the class distribution, and here we have correlation matrix, accuracy, precision, recall, FN score. Now click on sign out. In this way, just by giving inputs to the application based on the given input, we will get the prediction whether there is an attack or not. If there is no attack, it will just show that there is no attack. If there is attack, it will detect which type of attack it is. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.